Okay, so our last section for this chapter in geometry, section 1.6, we're going to work on midpoint and distance in the coordinate plane. So objectives, we're going to apply the formula for midpoint. We're also going to use the distance formula, which is actually an application of the Pythagorean theorem to find the distance between 2 points. So vocabulary for today: coordinate plane, leg, and hypotenuse. Not a big list today. So let's just jump right in. A coordinate plane is a plane that is divided into 4 regions by a horizontal line, also known as the x-axis, and a vertical line, also known as the y-axis. I'm sure you're very familiar with these. We use this to determine locations, and we use coordinates to determine those locations, also represented by x and y. Okay, so we might have an x and a y for this point out here in space in our coordinate plane. You can find the midpoint of a segment by using the coordinates of its endpoints, which is basically just calculating the average of either the x coordinates or the average of the y coordinates of those endpoints. And if you remember from the other day, midpoint, okay, splits a segment in half. Let's put that. Divides in half, where each side is equal. And here we go. This is the midpoint formula. So if I'm looking at the midpoint of the x coordinate, put x core here. I'm taking the endpoint x1, adding it to x2, and dividing it by 2. x1 right here, x2, and to find the midpoint, x1 plus x2 divided by 2. We'll do the same thing with the y coordinate here, which will give us this point right here in the middle. Okay, this is a really good diagram to mark and remember, to kind of go over the basics of finding the midpoint and actually what it looks like and where it's represented. So a little hint: plot the segment's endpoints on a coordinate plane. Okay, so if you have coordinate plane paper, this is a great tool to use. Set up your coordinate plane, okay, and plot your points, okay, those endpoints. That'll be really helpful to visualize where your midpoint should be, okay? All right, so let's work on an example so we can practice how to find the midpoint. So our question in this example is finding the midpoints of PQ, whose endpoints are given by -8 and 3 for P and -2 and 7 for Q. So we're going to reference back to the midpoint formula here. Okay, this is for the x, this is for the y. And we're just going to use those formulas. So here's our picture. We talked about drawing before. Okay, just to get an image. Now we think the midpoint is going to be somewhere here in the middle. So it kind of gives us an idea of what our answer should look like. So start off with the endpoints for the x values, right? So I'm looking for x here and x here. It's always the first. We'll add them together and divide by 2. We'll do the same thing for the y coordinates. Y and y. Okay. And divide those also by 2. Okay. When we work through this, we should get an endpoint, or sorry, a midpoint, -5, 5, which would make sense, right? Draw it right in there, -5 and 5. All right, here's another one for you to do on your own. We want to find the coordinates of midpoint EF, where we're given endpoints -2, 3, and 5, -3. So go ahead and pause the video and work out this problem to find the midpoints. Okay, let's see how we did. So again, start off with a drawing. And again, we think the midpoint's going to be somewhere here in the middle. Okay, kind of give us an idea. We can kind of maybe even make a circle where we think it's roughly going to be. and then we'll substitute in our endpoints, right? Starting with the x values. So we're going to have a midpoint for the x value, and I'm going to label it as xm for the x midpoint is 3.5, right? Or not 3.5, 3 halves, right? Which would be 1 and 1/2 for x. Okay, right there. That's interesting. Now let's look at the y's. So here we have 3 plus a negative 3. Of course, that's 0, and divided by 2. We get a 0 for the y coordinate of the midpoint. Makes sense right there. Okay, so if you were able to get 3 halves and 0, you've done well. Okay, let's say that I actually know the midpoint, but I'm missing one of the endpoints. So in this example, we have m as the midpoint. Okay, these are the coordinates for my midpoint this time. And we have the endpoints for point x. What I want to know is the endpoints for point y. So let's have the coordinates set equal to x and y. Okay, we'll start here, and then we're going to use the midpoint formula. So I like to set it up like this, right, just to give a good start. Right, here's my coordinates of my endpoint, right, endpoint x. Here, yep, sorry, this is our midpoint, okay, and these are my endpoints for x. Okay, so that's step 2. So if I want to find the x and the y coordinate of my endpoint y, we're going to set those coordinates equal to what I know the midpoints are already. So in this case, the midpoint for x is given here, right? You can know that from our previous information. This is the endpoint for my first point. And all I'm doing is I'm going to solve this equation. Okay, so that goes back to our algebra skills. Multiply both sides by 2, simplify, and we end up with a one-step equation here that we can solve for x by subtracting the 2. And we find out that the endpoint is 10. Our other endpoint, coordinates of y for our endpoint, are going to be 10. Now for the y portion, okay, the y coordinate of point y, we'll do the same thing. Set the coordinate equal to the midpoint of y. Right here, I'm going to just label it like that. This is the endpoint for point y, which may sound a little confusing. But now I'm at the point, once I get it set up right here, I can go ahead and solve that just like any other algebraic equation. Multiply both sides by 2, simplify, right? And you notice, if you remember, cross-canceling here. Those will cross-cancel. We end up with a one-step equation. Subtract 7 from both sides. We find out that the y coordinate of point y is -5, and we'll drop those in. This is the endpoints, okay? Coordinates y. This is not a bad idea on this also, is to draw yourself a diagram, okay? So I'm going to let you try this one on your own just to practice what we've just gone over, okay? And then I'll come back and we'll revisit your answers. So go ahead and pause the video and give it a try. Okay, let's take a look. So again, we're going to set the coordinates of t, right? T is the unknown, right? We don't know the coordinates of this endpoint. We do know the coordinates of the midpoint S, right? This is the midpoint. So I'm going to label it xm. So I'll also label the midpoint for y. Okay, so in step 1, we're going to let the coordinates of t be equal to x and y. Okay, the coordinates of the endpoint t, right, be x and y here. So I'll go ahead and set it up. Okay, so the midpoint of RT, which is S, right, these are the coordinates of S. Okay. Remember, we're finding the average of the endpoints here, but I don't know the coordinates for the the x coordinate of t or the y coordinate of t. And that's what I'm looking for. Okay, so we're going to go into step 3 and we're going to kind of separate these. We're going to put the x part together and we're going to put the y part together. Okay. Okay. Let's go try that. Okay, so on that, up here at the top, I included what we started with, right? Our process of finding the midpoints. So set the coordinates equal. Okay, so I'm going to set the x midpoint coordinates equal to the average of the endpoints right here. Okay, looking good, looking good. I like it. Right, so now I'm going to multiply both sides by 2 like I've done before. Here I can cross cancel the 2's, and I end up with a one-step equation. -2 equal to -6 plus x. We'll solve that. And we end up with x, the x coordinate for t. And I like to label it like this, right? This is my endpoint. This is the x coordinate of that, so t sub x. Okay, let's do the y portion, right? So same thing. This is the calculation for the average of my endpoints. Okay, this is the y coordinate of t. And again, it's just solving the equation, so I'll multiply both sides by 2. We get our one-step equation to solve, and we find out that the y coordinate of endpoint t is 3, and now I have all the information I need for the coordinates of point t. All right, let's move on here to the distance formula. And like I told you before, the distance formula is actually kind of an application of the Pythagorean theorem, where these calculations right here actually determine the length of the legs of my right triangle. Okay? So you are welcome to try and commit this to memory if you want, or we can go through and learn how this is used, and then you probably won't have to memorize it. Okay? So let's use this example 3 to help us out. So I want to find the length of FG and JK, and then I want to know, are they congruent, right? Are they equal? Okay, so find the coordinates of each endpoint. All right, so we'll go in, we locate the coordinates of our endpoint on our coordinate plane. We'll put those in right here. And now I can use those in my distance formula to help me determine those lengths. So let's go back and do that. So distance formula, here's all those coordinates that we found. So if I want to find FG, right, I'm going to not pay attention to the other ones. That's why I eliminate them. And remember, x is first, y is second. And all I need to do now is substitute my values. Here are the x values I'm going to use. Here's the y values I'm going to use. Substitute them into my formula. Now it's just a process of doing my math, right? Using PEMDAS. So we'll do what's inside the parentheses first, square it, then find the square root. Okay? So FG we know is a length of 5. Good. Okay, let's find JK now. So we'll focus on my next 2 points. Same process. X values first, y values second. Simplify the expression. Okay, now here we're getting a square root, and we are kind of rationalizing this square root is what it's called. Okay, and now, I'm not sure, rationalize, let's spell it right. I'm not sure how many of you are comfortable with that, so it's not a requirement for my class. You can use your calculator to determine what the square root of 18 is and represent it as a decimal. Okay, but I do want to show you this. these two lengths are not the same, okay, which tells me that the lengths are not congruent. Those lines are actually not congruent, okay? All right, I'm gonna let you practice one on your own, okay? So we're focusing on E and F and G and H, right? We want to determine whether those two lines are congruent. So I'm going to have you stop the video, work through this, and then we'll work on the answers. Okay, let's see what we did. Now, like I said before, in step one, we just want to identify the coordinates of each point. So we'll put those in here. You can check them against your own. If you find anything incorrect, you can work to the side and rewrite it. Okay, so now we're back to using the distance formula, and I'm going to work with finding the length of EF first. So X values, Y values. Let's go the right direction here. So I'll substitute in my X and Y values here into my distance formula. Then it's just a matter of simplifying. Okay, again, look, we find that it's 5, just like the last one. Let's see if GH happens to be the same this time. Ha! The lengths of my two line segments are the same. They're equal, which means that the line segments are congruent right here. Okay? Good work. Okay. Let's look at the Pythagorean theorem here real quick. Like I told you, the distance formula is kind of based on the Pythagorean theorem. So what I've got here is you can also use the Pythagorean theorem to find the distance between 2 points. We're going to learn more about the Pythagorean theorem off in chapter 5, okay? But suffice it to say that in a right triangle, the two sides that form the right angle are called the legs, and the length or the side across from the right angle is called the hypotenuse. Okay? Now in our diagrams, when we draw a right triangle, we use A and B for the legs, and most times you'll see C as the hypotenuse. Okay? So here's a quick diagram you can use about the Pythagorean theorem. And if you remember the Pythagorean theorem from your algebra class, or even in middle school, this is what it would be. A squared plus B squared equals C squared, or some people write it as leg squared plus leg squared equals hypotenuse squared. Okay? So I'm going to pause this section of the video. We're going to stop it, and I'll include the next section in the next part of the video.